Hello friends, welcome to TechStudyCell. In this video, we will make a very useful IoT project to control our appliances where internet is not available from anywhere in the world. Say there is no internet available in the village and we want to control this lamp in the village from anywhere in the world with smartphone. So in this scenario, there should be a middle place which is not far away from the village and the internet connectivity should be there. Then we will place a ESP8266 there to receive that signal through internet, and after that it will forward the same signal to village through the LoRa module. For this project I have used the Blynk IoT platform. So when you try to control the appliances from the Blynk IoT app, it will send the signal to Blynk cloud. Then the NodeMCU or ESP8266 will receive that signal from the Blynk cloud through the internet. Then the NodeMCU will forward the same signal through the LoRa module to receiving LoRa circuit. Now I have used Arduino in the receiving LoRa circuit which is present in the village. Now receiving LoRa module will receive that signal sent by the NodeMCU. Then it will feed the signal to Arduino and Arduino will turn on and off the related relay and send the feedback to NodeMCU again through the LoRa module. Now NodeMCU will receive that feedback and it will forward the same feedback to Blynk cloud, so we can monitor the real-time feedback in the Blynk IoT app with this project. Now soon we will see all this in practical, but before that I will highly recommend you to watch the complete video, as during the video I have shared the complete circuit, code and all other required details. So here you can see this is a transmitter circuit. Although I have used PCB, but you can make this just by using NodeMCU, push button and the LoRa module. And for the receiving circuit I have used Arduino relay module and the receiving end LoRa module. And Blynk will send the signal to NodeMCU, then NodeMCU will send the signal to Arduino through this LoRa module. Now let me control this 4 lamps which is connected with this relay module from the Blynk app. Now if I tap on the first button in the Blynk IoT app, the first lamp will turn on, and after receiving the feedback it should show feedback received. Now let me tap on the second button. The second lamp turns on and as you can see again it is showing feedback received. Now if the NodeMCU is not connected with the Wi-Fi, then this blue LED will turn off. Then you can control these appliances with this push button. Now let me press the third button on this PCB and the third lamp turns on, and after receiving the feedback this green LED turns on, and as it is connected with the internet, as you can see blue LED is glowing, so we can also monitor in the Blynk feedback received. So in this way you can control these appliances which is not connected with the internet from anywhere in the world. In this video I will use the RYLR998 LoRa module from React. You can control this LoRa module with some basic AT commands which we will see during the video. Now this is the transmitter LoRa circuit. You can easily make it just by using NodeMCU, LoRa module, some push buttons, LEDs and some resistor. I have used these 2 resistors just to drop down 5 volt logic level to 3.3 volt for this LoRa module. You can find the required component list in the description. Now this is the receiving end LoRa module circuit, and here I have used Arduino as a microcontroller, and again I have used these 2 resistors just to drop down 5 volt logic level to 3.3 volt for this LoRa module. Now for this project I have used a PCB for this transmitter LoRa circuit to make the circuit compact, but as I said you can also make the circuit without using any PCB. But if you want to get this PCB, then you can download the Java file from the video description and order it from the JLC PCB. You can order any custom designed PCB from JLC PCB with 3 simple steps. First, upload the Java file. Then select the parameter like quantity, PCB masking color. Then place the order. If you select faster delivery service, then you will get the PCB within a week. and as you can see, the quality of the PCB is very premium in this affordable price range. So you can always try JLC PCB for your any custom design PCB project. Now these are the components required for the PCB. Now I will quickly solder all the components on the PCB. Now I will connect the NodeMCU on the PCB. Then I will connect the LoRa module with the PCB. And here I will not use any OLED. In future video I will add that features. And now our PCB is ready. I will give the 5V supply at this place. Now before going to the coding part, I have to configure the Blynk account for this project. So after login, I will go to templates, and here I will create new one. So I will click on new template, give the name LoRa ESP8266. You can give any name. As hardware, I will select ESP8266. Connection type should be Wi-Fi. Then click on done. Now I will go to data stream. Then I will select virtual pin from new data stream. Here I will give the name for the first data stream switch 1, and in the pin I will select V1, and data type should be integer, and 0 will be minimum value and 1 will be the maximum value. Then I will click on create. So in a similar way I will create another 3 data stream with virtual pin 2, 3 and 4. So as you can see, I have created this 4 data stream to control 4 relays. Now I will create the last data stream to monitor the feedback. So again I will go to new data stream and select virtual pin. Here I will give the name status, and in the pin I will select V5, and data type will be string. Now click on create. So we have created all the data stream. Now I will go to web dashboard, and here I will click and drag 4 switch widgets to control 4 relays, and I will use this label widget to monitor the feedback. Now when you hover over the switch widget, you will find a setting icon. Click on it, and here I have to select the data stream for each widget. For the switch 1, I am selecting switch 1 data stream which we have just created. Now click on save. So in a similar way, I have to select data stream for all the widgets. Now after doing all this, click on save. Now I will go to the device. Just click here. Then here I will click on new device, and here I will select from template. Here I have to select the template which I have just created, which is LoRa ESP8266, and you can give any device name, but I am keeping as it is. Now click on create. As you can see, I have got the authentication token, template ID and the device name which will be required in the coding, and you can also get these details in the device info. So if I click on the device info, you will get the same details here. Now we will move to the coding part of this project. So these are the codes for this project. This is the code for the transmitter and LoRa circuit which will upload to NodeMCU, and this is the code for the receiving and LoRa circuit. I have to upload this code to Arduino. You can download the codes from our website iotcircuithub.com. Just visit the article link given in the description, then you can download the code from this button. After that, I have to update all these details. So I will go to Blynk IoT account, and as I said, in the device info I will get all these details. So I will click here to copy this. Then I will go to Arduino ID, and here I have to paste these details. After that, here I have to enter the Wi-Fi name and a password for the Wi-Fi. Now for this project, I have used the 865 MHz band for the LoRa module. You have to update the band as per your country. In my country, 865 to 867 MHz is the eligible band for LoRa. So I have set it to 865 MHz, and the LoRa band and network ID should be same for both transmitter end and the receiving end LoRa circuit. Here I have used the LoRa network ID 5, and here for the transmitter end LoRa module I have used the address 1, and for the receiving end LoRa module I have used the address 2, and the transmitter LoRa module will communicate with the receiving end LoRa module having address 2. So here I have mentioned 2, and the receiving end LoRa module will communicate with the transmitter end LoRa module having address 1. So here I have mentioned 1. So if you want, you can change these details, otherwise you can keep it as it is. After doing this much of changes, you can directly upload the code to NodeMCU. For that I will go to tools, then you have to select the NodeMCU board, then hit the upload button. After that I will upload the receiving end LoRa code to Arduino. So I will go to tools, select the Arduino Uno board and proper port, then hit the upload button. And as you can see here, I have used the software serial library in both the code, so you don't have to remove the LoRa module while uploading the code, as I have used the different GPIO pins for the serial communication with the LoRa module. Now I will configure the Blynk IoT app, and if the NodeMCU connected with the Blynk server, then this blue LED will turn on. So as it is on, so I can configure the Blynk IoT app. So I will tap on open, and we have created this template LoRa ESP8266. So I will tap on this template, and here I will tap on setup dashboard. Then I will go to this 3 dash icon and add 4 button to control 4 relay. Then I will add the value display widget to see the real-time status. Let me resize this. Now I will tap on first button, and here I have to select the data stream. For the first button I have selected the data stream switch 1. Mode will be push. Then you can exit from this button. So in a similar way I will configure all the buttons. You just have to select the data stream and the mode will be push. Now I will tap on the value display widget, and here I will select the data stream status which we have created with the V5 virtual pin, and I will also increase the size of the text so that we can monitor the feedback clearly. Now I will exit from the mobile dashboard. Now if I tap any button in the Blynk IoT app, you can see it is showing waiting for feedback, and this LED is blinking, which indicate now it is waiting for the feedback. And after certain time, if the feedback not received, you will find this feedback not received. As you can see, I have connected these lamps with the relay module. Now let me turn on the supply for the Arduino. Here I have to wait till the LED turns off. Now let me give the supply to NodeMCU, and for the NodeMCU circuit again I have to wait till the both blue LED turns on and this green LED turns off. So this blue LED turns on, which indicate now it is connected with the Blynk server. So now I will tap the first button in the Blynk IoT app, and you can see the first lamp turns on, and here it is showing feedback received. Now let me control it from the manual push button. Let me tap the second button in this circuit, and again the second lamp turns on and it is showing feedback received, and also this green LED turns on. So in this way we can control these 4 lamps both from the Blynk IoT app and from the manual push button. So this is a very useful IoT project. You can control the appliances where Wi-Fi is not available, and in future I will try to add more features to this project. So if you find this project helpful, then please hit the like button and share it with your friends. Don't forget to subscribe for more such projects. Thank you for watching. Have a great day.